Okay, let's wrap that up. Property animations. So, if you, I'll show you a bit of an example, some brief intuitions of how to approach this in principle, and the rest we just run through some examples and see how it's done. I don't think it will take us until 4 o'clock, but we'll see. Anyway, so how do you generally do property animations? Relatively straightforward. Well, you want to figure out the object you want to modify. Generally should be a view, most likely, so it means it actually shows some UI. And you need to identify the property that you want to modify. And the interesting thing is there that you actually kind of look into the Android API fundamentally and check what the internal property actually is. And how it works with reflection is, you see it here as a demo down here, if you look at it. So the animator, you get an object animator, you kind of know you're operating on float values. You need to specify this one here, object animator of type float. You identify the view you want to modify. And then the property that you actually want to, of that view that you want to modify, and you're literally typing in the name of that property, how it's internally represented. And the assumption is there that the property must be accessible using getters and setters, right? Everything that's settable via set name or get name and so on is in principle accessible to this property animator. And that's the key idea, that we're no longer just assuming views, we're assuming properties primarily as a way of differentiating. So you kind of need to type it in and sometimes to some extent guess the properties. They may not be always documented, but if you see a set scale x, well, then the variable is very likely scale x, in this case then with a lowercase by Google Java conventions anyway. Yes, cool. So, and here's the value, right? So that's basically a parameter you want to set this value to. Scale x is basically scale along the x-axis by factor 2, right? So go double the size. Duration, quite straightforward. So we get a reference to this animation basically by using, or to the object animator prior to execution. And then you can parameterize it further, right? You provide, for example, the duration it takes to do the process, and the interpolation function. So we're coming back to the interpolation. In this case, could be here's bounce interpolation, could be linear interpolation, could be accelerate interpolator, decelerate interpolator, and so on. There's a set of them. And then you start this thing. That's fundamentally it. Slightly more parameterization, but you probably appreciate that it's slightly more flexible as well in terms of what it can probably do. In fact, this will suddenly allow you, if you come up with your own view, to extend the property set, right? Suddenly modify properties that would be interesting to you, whether or not they're actually visually represented. It's just modifying properties, right? So it's much more powerful in a way doing this. Cool. So so that's basically the whole operation. So let's see if we can come up with a simple example. So that is the view animations. Let's do from here on property animations, and you can do something like object animator. There you go. We call this thing animator for the sake of consistency for now. You get no, it's technical pattern of type, most likely float anyway. So you want to modify a view. So in this case, if any view is probably called, modify that particular view. Now the property, and then you kind of need to know about the properties that a view potentially has. So a cheap way out is, of course, to look at the property itself and look at get and setters. Ideally, of course, the ones with numeric values, because only then you can do proper interpolation, unless you write your own interpolator that can somehow magically works with string as well, right? So you can do that as well. We'll see that in a second, what options you have. But anyway, so fundamentally, you can choose any of those properties and modify them. Of course, I'm taking the easy route here and using a property which kind of makes sense, such as the rotation again. So, and the target value, which is like, whatever, 90 degrees, I guess. Cool. Right. So, Android Studio is actually quite helpful here. So if you have an invalid value, it actually performs reflection already at compile time. It actually checks whether your reflection will work out at runtime and says, hang on, I could not find a property setter method, set rotation CX on Android view. So it shows you exactly how it actually accesses the properties, right? So it expects a setter, and if you can't infer a setter that corresponds to the variable name, in this case cat set rotation X, then it will complain. So it's actually quite neat from the UI to actually deal with this prior to execution, right? So quite neat. So Object Animator, the rest is roughly the same. That was my screen. It's coming back. Hang on. We're setting a duration of 300. For the sake of it, since we haven't looked at it, set the repetition as well. Repeat count. We can repeat it 3 times, so we have a bit more of an animation going on, perhaps, who knows. Yeah, let's leave it at that. And then, while we're initializing the animator early, we can then separate the execution and only perform the execution down in the actual switch statement for a corresponding button, so we can spread it out a bit and only run a subset, use a subset of the buttons for the actual animation. So let's see. They all still look ugly. So I use button 0. That must be the top left one. Help. Is it still running? Oh, there was an error. Beautiful. Okay. Okay, let's try to ignore that error. Cool, we can ignore that error. Pretty good. Right. So what do we have here? Well, we can actually do something to it. And you saw there was an animation running 3 times, and that kind of, since we, oh, that broke the whole thing. That's clever. Yeah. And since we didn't reset the state, it kind of stayed in this odd, very kind of very odd rotated variation. So what you can do in order to mitigate this is to go back here and say, where was I? You can reverse the entire exercise, of course, but the more proper way is to actually set the repeat mode, and that says, okay, how does the values actually end up at the end of the animation. So let's see if that works a bit better. Hang on. Okay, it does something. Hang on, 1. Okay. I think I broke it. Beautiful. Okay. Sometimes it doesn't quite work. Note though that the animations are often highly sensitive to the device instance you're actually using, so it may sometimes go in different directions than you expect. Let's play a bit. View. And use some other properties, see if that works better. So let's see. Okay. So if I do a repeat count of 2, it probably works more reliable. I'm missing some. Yeah, I was starting something here. Silly me. Buttons are back. Okay, hit in that state. So the return state is number 3. Change change back. Okay, third one. All right. So let's animate this on top of this with another property. Let's change. What is numeric? Ah, yeah. Well, what is the good old alpha value? So we can play with transparency as well. Make it semi-transparent. So animator 1 start. So we can do that at the same time. Hopefully, I probably, in case I repeat this exercise, should revert to the original state. Let's see if that where we end up here. Okay, still in this odd state. Damn. But it's half semi-transparent, so if you haven't seen that, that should work easily as well. So it's basically just, you know, changing the alpha value of a particular button. That's a quite straightforward thing as well. So to show you a bit about combination of animations, that is probably a bit more meaningful. So you can come up with a bit more complex setups. So we have the object animator again, the good one. Animator of float, view, and then rotation. Can rotate around the y-axis for a change. I can do that as well. Do 360 degrees, so we'd expect a full flip of a button, for example. We always need to set the duration of this thing. Duration and 1 second. Spend some time on that one. Animator 2. This one first. And so that gives us a rotation, and at the same time, let's scale that whole thing as well. So let's combine a bit. Animator 3, you see the pattern. So basically you have a set of different animators for different purposes. This was scaling 3. So this is Y. The combined scaling doesn't really work well. I think there's a call to that, but it's not consistently operating on virtual devices, so I'm down to actually doing it manually. So this is 200. This one is animator 4. So let's see if we can combine that to something. Cool. And then there's the animator set, and then yeah, whatever. So that works. New animator set. And then you have a set of options. They're quite interesting. So you have the ability to you know, play individual animations, set the overall duration, of course, but also decide whether, for example, you want to play animations sequentially, and that gives you a much richer portfolio of what you can do, right? So if you, for example, try to combine, let's try to combine all of them, see if we get a meaningful outcome. Perhaps not. Perhaps we need to revisit that a bit later. And you have an animator set. Playing at the same time. You play this whole thing for a duration of the longest value, which is 1 second, for example, and then you just say animate, no, not that one, this one, and then start. So let's try that one. That is linked to button 2. Right, so let's try that. See what surprises we get. Button 2 is this one. Yep, that's roughly not what I expected. I scaled, I did some rotation. Let's get rid of the first animator. I think that is a bit screwed up. I'm not sure what I did wrong there, but probably I did. What did I do? So we have an alpha value, we have rotation x and 60, we have a scale. Yeah, I should roughly be it actually. And play sequentially. So one of the other in this case. Right, hang on. So hang on. What do I do? X and Y. Let's make another animator set here first. Set scale. New animator set. Scale, and then you can say place together. That's the one I want. And we group within the actual bigger animator set those two animations for scaling, so they actually occur at the same time, and the other ones are sequentially. So here we now substitute, making it gray first. What was animator 2? Animator 2 was doing the rotation, and following this one we kind of set the scale. So let's see if that comes out a bit nicer. They are played together, they are sequential. This, probably I can just get rid of this entirely. Right, so it kind of, the scaling was at least synchronized, so it's guaranteed synchronized if you want to, of course, do everything together. Let's see how that goes. Play together. It's quite straightforward now to actually manipulate the animation behavior without redefining the actual individual animation. So it's quite nice from composing complex, a bit more complex animations, if you like. So yeah, it does it at the same time. You, of course, are responsible for timing. Right now, the button scaling was too fast relative to the movement. So we change that to not 10,000, but 1,000, and so on. So come on, right. So it incrementally increases, turns, and does all its magic. So sounds okay so far, right? So only thing is there. What's actually slightly annoying in this API, which is not properly solved, is actually reversing to the original state. So you would expect to say, well, you know, let's call reverse on it and see how it goes. Let's try that out. See it perhaps. Because if you deal with this, you find various ways that people suggest how to deal with reversing animations, because you want to get back perhaps to the original situation. Let's see if it actually works with the nested animator set. Because the idea is that it calls reverse on all the nested components. And they basically just play back the animation in a reverse direction. Ah, it actually works. Cool, nice. Actually not too bad of an effect, in fact. So, okay, cool. But for some cases, it doesn't really do the job sometimes. Sadly, it does here. Good, that's good. Okay, good. So, anything else I want to show you on this one? Well, not really. I think that covers most of it. The point is, if you have problems with the all right, yes. So if you have problems with the reverse animation, one other way of dealing with this is actually you can add listeners to a, there you go, to an animator. So set animator listener adapter. That's roughly the thing. So, and it gives you quite a bit of stuff to choose on, right? So that you can basically say, okay, before the animation start, do the following, right? So you have much more opportunities to actually modify your properties at runtime. So, and conventionally those two ones on application start or end are often useful. Of course, it doesn't make sense to implement everything. But on application end, that is usually a good option for actually undoing the animation in case you want to redo it and don't have the opportunity. So the pattern would be to remove the listener again. And basically then reset all the properties here, right? So you can basically say, well, set everything to 0 or something like this, the original value. Or you can use something like a reverse interpolator. So that's also a suggestion done. It's particular for older Android versions where reverse doesn't really reliably work. The idea is there that you take a linear interpolator, if not otherwise specified, and, well, just invert the interpolation, right? So basically instead of, so the interpolator interface basically works as follows. So you implementing the interpolator, overriding constructors, and then have a get interpolation call, which is done by the animator, the object animator in particular, and it provides you with an input, and you then internally determine the output, right? So by inverting it, basically 1 minus interpolator get interpolation. So you're using the default interpolator passed as part of the constructor, you get the inverse value basically. And then you can undo the animation using this way. So fundamentally the idea is to, let's see if we arrive at the same kind of result. If you say animation set interpolator, that thing, animation.start. So see that we get rid of the reverse here. Animation. So don't. So if you say set duration, that's the trick here. This basically means reset everything to the final value, pretty much because the duration of the animation is 0. So basically you. That should preempt any inverse animation, in fact, so, but just return you to the original value. But again, in this particular case, reverse actually works, so it's good surprising. But in case it doesn't in your emulator, don't be surprised, because it's kind of a bit of a, it works well. So it actually returns immediately. If you extend the duration, it probably smoothens the reverse animation a bit. Well, hopefully. Ah, yeah, it so actually reverse animation. So it does the whole thing backwards again, right? So, yeah, cool. Okay, so relatively straightforward, right? So no magic there, right? So you specify individual animation, group them, nest them, indicate the execution order, for example, sequential or concurrent. So that's relatively straightforward. And you can play with different interpolators. Now we play just with linear, but you could have an acceleration feature. Ah, hang on. So hang on. Could actually put that in if you have an animator to make it a bit more. 5. Ah, come on. Object animator 5. Object animator of float. View, and then property is the translation. There. Y, and then you say something by Y. Let's say minus 1000 something. So let's see. Obviously, I got the value wrong, but if you play with the translation, it can also be a bit fun. Just translation Y in this case. Right. And then animator set, final set, new animator set. Then you just pass along. So if I have a final activity that you just have a kind of a flyout effect, see where it works. Animator set starts, embedded in the animator set. Ah no, I actually need to call the final animator set, sorry. Final set. Yeah, but anyway, so yeah, if you make it higher, so let's see if I can target the animator 5 set interpolator. Fundamentally, you're calling get animated value to the animator object. So based on the initial values, for example, on the start property value and end property value, the animated value would spit out the current progression in the animation, and the corresponding object will be updated, and any change on in the update will basically modify the modify the value basically, and you know, you have an iterative cycle in which you can actually listen to updates in your particular object, or you can actually drive the changes based on the value animator. So the value animator just retrieves the interpolation, the current value of where your progression actually is, right? So different forms of interpolation, we talked about this briefly, intuitively, having different functions associated with this. So in addition to the encode specification, you can of course specify this whole thing in, of course, XML again, right? So our beloved comprehensively specified format. So in this case, how that works is you fundamentally, show you an example. You specify this in the res folder. So you have the res folder, and you create a new. If you say create new folder, it will actually allow you to. Wondering if it asks me. Yeah, it allows you to specify new resource folders. One of them called animations. So all animation specification are in a new resource folder with the name anim. So you need to explicitly choose this here in the dialog. And then you can specify all the kind of different animations that you probably want to do, right? So for example, here's modifying of the alpha value, kind of a fade out effect that you have. You can have a rotation effect, which would be specified as follows. For example, you rotate starting from a particular degree to an nth degree, pivotal effects around different axes, the duration of it, and so on. So it's kind of a neat way of separating your animations from the actual code and just calling them in code, so it makes life a bit easier. How do you do the calling in code? Well, relatively straightforward. So here, this is a demo where we have different buttons, and they're all basically demo the functionality individually. I just start this thing. It takes a while anyway, while this is doing this. And for the individual animations, when a button is clicked, for example, use animations utilities to load a particular animation. Further, of course, a current application context, and then you reference the individual resource using the conventional R notation, right? R named, folder name, and then the XML file that you actually want to point to, and then yeah, basically start the animation, right? So in this case, it makes this view visible in the first place, and then starting the animation on a particular view. That's the idea there. Quite straightforward. Let's see if we see some. Oh, timely. So we blink something. So basically, the idea is to have buttons on the left and some sort of animations on the right side, and then you can emulate those ones and just explore them. But they're fundamentally all specified using this XML notation. And you know, for example, you can do translations that take the following properties of duration, the start offset, starting delta, and the end delta in the end. So 75% move there, and so on. What else? Rotation and so on. So it's just a matter of clicking through the properties and comprehensively specifying them. So there's multiple ways of doing this, quite straightforward. But it requires you to look up the API, of course, and play with this as well. Yeah. Yeah. So the last thing I briefly want to point to is transitions. So if you have multiple activities, so you want to have smooth transitions between different activities by having, you know, movements to left, right, and so on. When you change the apps, you can do that as well. It's roughly done the same way. And the idea is that you specify the the transitions in XML, and then you actually call them after start activity. So if you call a new activity, I'll try to demo that. Let's see how it goes. Let's see. Going back to our original demo. So right, so we have a main activity here. There's a certain set of animations. So let's use my button 3, which hasn't been used there yet, and we want to have, I think, context, if I get it right, and main activity 2. And then start activity. Like that, roughly. Intent. And following the intent, you then make a call. Well, that's a handful. Basically, you make the call to override. That was the one. Override pending transition. Not that way. Sorry. Do it inline. And then you navigate to the animation folder. So it happens, though, of course, that I there's some animations here. So it's basically how it's doing. Fundamentally, the animation here is the translation. So you're moving in and out. So basically, you're in this case, it's a movement from x delta minus 100. So from outside of the screen into the screen, sliding from the right if you want to do the opposite, and so on. So it's basically how you just specified. You can slide from the top to bottom. So yeah, the approach is relatively straightforward. You basically indicate the starting point, the end point, and indicate the speed with which it's going to happen. In this case, it's the animation time that is pre-configured in Android for that purpose. So fundamentally, you just link the, I think the order is here is the incoming animation first, and the outgoing second. Yeah. If I got that right. Cool. And then in the target activity, if you want to set behavior there, for example, if you want to modify the behavior when you press the back button, you do the same thing. You basically override on back pressed, and then override the pending transition transition animation associated with it. Yeah, that's the one. Cool. So it was button 4, I think. Yeah. So yeah, basically you have some sort of animation, and then when you press the button, you're moving back. Basically, it rolls you back to the original animation. Of course, you can easily modify that and make that. What do we else have? Top, something like that, and so on. So here it's really about looking up the syntax and modifying accordingly. Put it in the anims folder, and then just use it in your application if you can. Please, please.
Can you do the same thing if you're changing fragments? Can you create animations between changing them?
That's a good one. I don't know. I haven't tried that, to be honest. I only looked at it from an activity point of view right now. need to look it up. Yeah? But fundamentally, it's quite straightforward. So if you want to do a bit of navigational, you know, whatever, cleverness, I don't know. If you want to explore it, use that facility. It's quite straightforward. Once you got the syntax right, to be honest, a bit of fiddling around until you get it. But it's fairly reusable, right? Because you put it in the anims folder and you can just copy it around. It's inherently app independent, right? So you can just carry it along once you figure out the transitions. So, and that's actually quite straightforward. Yeah. So yeah, you can also go further than that and actually nest transitions. So if you have an application and you want to actually manage different scenes of that, or use different activities at different scenes in that application, you can actually kind of have a nested specification of transitions that basically is applied to all subsequent scenes set of activity in a hierarchy. So you can do that as well. Quite involved, of course. I didn't have a demo for that one. But I just wanted to show you the individual components that you actually use, right? Animations for transitions, animation sets, yeah, and the difference between view animations and property animations in Android. That's basically it. Is anyone keen trying that out for their labs? For their assignments? Doesn't look too hard, right? So it's a bit of mucking around, but once you've got it figured out, it's actually quite straightforward and relatively easy to establish. I put both links there for both the view animations and property animations, so you get a quick link into it. Again, bear in mind, view animations are considered deprecated. I suspect they're going to be kicked out of Android in future versions, but so far they're still existent, they still work, even on Android 9. But just bear that in mind. So the proper way of doing it is using property animations anyway. Questions? Nope. Yeah, there's no magic there, I guess. I mean, it's nothing particularly challenging. Okay.
We understand the tests.
Sorry?
It's magic that we understand the tests.
That's right. So yeah. Well, I'm not saying at least, but yeah, if it's magic, yeah. But you get the gist of it. That's the main thing. Starting point for playing around with this. So tomorrow is a bit odd one. How many of you actually have graphics? Yeah, most of you, right? So some of you not. So that's cool. So tomorrow I'm planning to talk about graphics on Android in a way. And this will be geared at non-graphic students, right? So giving an intro, you know, OpenGL pipeline, all those principles. So I suspect that tomorrow's session, while in principle everyone is invited to come, of course, it will probably be a bit of an overlap or feel like a bit of a repetition of what you've heard in graphics in particular already, while geared more towards mobile devices. But you know, but so it's a bit up to you whether you want to come or not. I'm not excluding you, of course, but I just want to warn you that there may be stuff that you have heard about definitely already in graphics, right? But it's important that everyone hears about it and understands how the OpenGL pipeline basically works, how you could use it in Android to some extent. We'll not really go into demoing it, but rather showing the feature set that you are available on mobile devices to some extent. So a bit of a high-level overview, just as a preparation in case you want to decide whether you want to get up at 5 to 10 tomorrow to be on time in class or not. So so much about that, right?